Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. My guest today is Sanjay Krishnan. Well, first of all, he's an assistant professor of computer science at University of Chicago. We're going to talk about why, I guess from just a layperson's point of view, AI all of a sudden seems to be a successful, useful product. And there's all these emergent behaviors, I guess, that I didn't think were possible, and they're here the past 2-3 years. And we'll go over AI in general and what's new. So welcome, Sanjay.
Thank you for having me. This is a wonderful opportunity and happy to share my perspective. And I think I just want to emphasize that as an academic, this is my perspective. I am a technology optimist by personality, and it's worth hearing other people's perspectives on AI, but I'm hoping that mine will shed an interesting light on how I think about the state of the world today and where it's going to go.
Yeah, let's start out with AI. Like, why all of a sudden it seems like 2023, AI has been around for like 50 years and, in small forms, I guess it used to be called expert systems. Why all of a sudden is it so much more useful than it used to be? What's changed?
Great. It's this is kind of a loaded question, right? I think that when we as consumers of technology look at technological development, we often look at things as like abrupt jumps. As somebody who's been in the AI field in one way or another for the last 15 years, this has been kind of a slow trickle where what we're seeing today is, I think, the natural progression of where the technology was going to go even 15 years ago, right? Not that we in the heat of it knew that and understood that it was going to move this fast, but there's been kind of a slow uptick of capabilities that have been incremental and progress building on each other. And really today's moment sits at a confluence of three factors: data, compute, and usage, right? So we kind of have three different pieces that make AI powerful. First, you need a large amount of data because today's AI fundamentally replicate the behaviors that they see in human data. So you need large amounts of human provided data. Then second, you need large amounts of compute to be able to turn that data into patterns and into models that we can then replicate the human behaviors in that data. And finally, you need usage, which is something that we forget about in this kind of picture. We usually just talk about data and compute, is that you need real world use cases of people using these models in practice so you can go back to the drawing boards when something isn't working right? And the confluence of these three factors leads to the AI systems we see today, right? And I think I read an article that ChatGPT is queried multiple billion times a day. That's a significant amount of usage that also adds to, I think, what's usually seen as the two knobs that control AI, which is large amounts of data and large amounts of computers. I think that what we've seen today is like the confluence of these three factors has, I think, created a noticeable improvement in the capabilities of AI systems.
So just there's now so much more data and, systems can be trained on just more disparate areas of knowledge or so many areas of knowledge that now it's becoming more useful to the areas we really want to get info in.
I also think that it's a couple of different things, right? I think that I like to think about it as a lot of these resources were there. It is just the right time and place, right? If we think about the internet as a product, it is a effectively a distributed, decentralized expert system when you really think about it, right? And you have all of these resources, everything that was being readily digitized, all this data was there. Then we started getting models and the computing infrastructure with large-scale clusters of graphics processor units to be able to make sense of that. And then finally, I think that because we had these two things at our disposal, the research community started viewing AI different. Like if you asked somebody in the 1970s and 1980s, in the early days of AI, how would you build something like ChatGPT? How would you build something that has human language? They would say, well, we need to hire all the linguistics professors in the world and get them to write down all the rules of human language. And we start with that basic set of rules and we work upwards into building more and more complicated emergent behaviors, right? Now, I think that when you have the internet and you have cloud computing and you have a elastic way of scaling your compute at your disposal, you start looking at the problem the opposite way. You start saying that, well, let's just assume that the internet is kind of a complete corpus, right? That means it covers almost anything that somebody might want to say linguistically. And all of those rules are just baked into that corpus, right? All we need to do is to kind of mimic the patterns of human language that we see in that corpus, and then we end up learning those rules. And that's what's really happened, right? So I don't think that anything we're doing today is incongruent with the way that people looked at AI before. It's not that kind of a technological eureka moment. It's more of we just happen to live at a time where we have these resources at our disposal, and it forced people to look at classical AI problems and language generation, image processing, and now a whole host of other problems in a completely different way because we have the data and compute available to us.
So things have incrementally gotten better, more data, more compute power, more layers and AI models, more everything. And now all of a sudden it's become very useful. Is it beyond the improvements in all the, the AI models out there? Are we getting any benefit from all the people that are using ChatGPT and Gemini and Grok and et cetera? Like where is all that data going? How's it being used and how is it going to benefit AI going forward and people's usage of it going forward?
Good. Wonderful. So this is a great question. And this is one that gets to the heart of my own research because I like to think about how these AI systems are ultimately going to take decisions that affect change in the real world, right? Like not just writing an essay with ChatGPT, but potentially having it like, hey, ChatGPT, I'm hungry. Can you fire off an Uber order to me, right? The second that you close that loop with the real world, suddenly the stakes get a lot harder and the systems around them get a lot harder, right? So let's talk about this usage question, right? And how I think about this usage question, right? So when I think about ChatGPT, I usually, this is something I tell my students when I talk about large language models and modern AI. It's actually very simple when we think about it. If I gave you a sentence and said, the monkey was eating a blank, almost everyone listening to this podcast is going to say, oh, well, it's a banana. That's effectively what an AI model is going to do. I told you nothing about this monkey. I told you nothing about what this monkey likes to eat. I told you nothing about the world in which this monkey lives in, if there even are bananas, right? But somehow, just from the linguistic clues that I gave you, you know that the word banana is highly correlated with monkey, and that is something that in at least Western culture, we associate those two words together, monkey and banana. Right? And that's kind of how a large language model really thinks. What it really does is it breaks up a language generation problem into prediction. It tries to predict what the next word or the next token is, or the next phrase in the more advanced models. So it's really doing this one-step prediction at a time with no context of the real world. Where the usage starts helping you is it starts grounding those predictions in real world interacts, right? For example, now if somebody gave me the monkey was eating a banana and I said, no, this monkey doesn't know about bananas, like do something else, suddenly that interaction starts helping ground this model into something that is more real in the world, right? Because you're sort of drawing a connection from the pure predictive world, which is just correlation signals in linguistic tokens, to an interaction in the real world, right? So I think that that's where all this data is really going to help, right? Because it's not just a matter of being able to generate language correctly, because this is not to keep on with the monkey and the monkey analogy. It's not just a monkey and typewriters problem, right? It's not just a matter of AI is not just a matter of generating all the text you can or generating all the images you can. It's about ultimately making products that are useful to humans, and you only get that signal about is this an actual useful prediction when you interact with the human. And I think that we're going to start seeing that boundary of data just keeping on growing, right? First is going to be just chats, right? It's going to be all of those interactive prompts saying that, can you make this better? Can you do this? Can you do that? All of that data data ultimately helps you direct of like, these are the types of solutions your AI model needs to spit out, and these are the types of solutions your AI model doesn't. The next step is the second that these AI models start interfacing with eyes in the real world, like Uber Eats, your calendar, your email. Suddenly, again, those interactions give you signal, am I doing the right thing and am I not, right? And I think as you start increasing those success signals, right? Or like the real world signals of like, are you doing something right? Suddenly the capabilities dramatically change. This is no longer a language prediction model. This is something that is actually making decisions in the real world. So to me, like, I think that usage is really that bridge between something that just generates language and honestly generates language in a mediocre way, right? Generates language with no context of the real world, short of what it has seen in its training data, to something that is actually interacting with people in reality. And usage helps bridge that gap.
Okay. And again, what's happening with all the stuff that people type into these different LLMs and AI models? Is it being recycled and now it becomes part of the knowledge base? And so that as people use it, the knowledge base is shifting and changing the answers they get? Or is it currently just being held and studied and, the models are unaffected by it?
I think that the answer is going to vary company to company, right? I think the answer is going to, and I think that where do we see AI research going forward? It's going to be understanding how to best use the data that we have, right? I think that there are going to be some companies that worry that that heavily incorporating novel data is going to make their models less and less stable and ultimately rot over time. There are going to be other companies that think that dynamically changing to real world data, dynamically aligning with people's preferences that they're seeing in reality is going to be beneficial. I don't think that there's going to be one right answer on the architecture here. There's not going to be, I think that a lot of people like to draw the search engine analogy here. I am not convinced of. I think that what's going to happen is a diffuse set of intelligent models that are out there, whether one is OpenAI's model, one is Facebook's model, one is Gemini, one's from Google, one's from Anthropic. Each one of them is going to cordon off a certain type of performance on them, right? Whether one is more factually correct than the other, whether one is more creative than the other, whether one aligns with like a better interpersonal communication than another. I think that they're going to use the data that they get in slightly different ways. And I think that that's going to be the market specialization that I sort of see that comes out of like the current AI wars that I see. So I think that right now, it really does seem like there are one or two players that are running away with it. But I think that the nature of this product is going AI or LLMs or any of these buzzwords as a product, I think is really going to come down to different people carving out different ways of using both training data and usage data to specialize their models or direct and steer the types of responses their models are giving in different ways.
Okay. So what's the main focus of your research right now?
Good. So the main focus of my research was I really like to think about what is the world going to look like if everybody was using a large language model. So we can kind of think about an analogy to the early days of the internet, right? That a lot of computer science researchers had to think about, okay, well, we start off with something that looks like a World Wide Web. There are a few research websites. What does the world look like if everyone's using it? Suddenly you start having to think about the cloud. You start having to think about security. You start having to think about how does this scale? You start thinking about content distribution networks and so on. I want to play that same game with large language models and agentic AI and the future of agentic AI. Let's imagine that every website that you visit regularly replaced a substantial part of their interface with AI generated content, right? So, I mean, and it might not be ChatGPT. It could be a much lighter version of AI generated content. Maybe it is just directing or summarizing text in a certain way, in a way that you like it, or summarizing the stories that you like. Now that leads to a whole host of new problems because the internet was not designed for effectively an internet of AI agents, right? It was not designed for a world where everything on this internet is an AI agent, because there are all sorts of unique challenges that arise. First, there's just the raw compute, right? That it's like, how are we going to build the data centers to manage that kind of load? Second, there's also new security questions, right? What does cybersecurity look like in that world, right? Now, these are not just static websites where you can lose your password. They're static websites that can leak data in weird ways. They can interact with each other, can have weird feedback loops, can ruin the reputation of your company by saying something odd, right? So there's like all sorts of new cybersecurity threats that arise and all sorts of new data leakage vectors that arise. So what I'm really now focused on, or actually I'm algorithms researcher by training, but as this world of AI has opened up, I think that focusing on what does that cybersecurity infrastructure and what does that scaling infrastructure look like is really the focus of my research going forward. And I'm excited for that world. And
where will this security be needed for the average person? Maybe not someone that's working at a company, but again, just average person.
Oh, I like so many things, right? That, when you are talking to ChatGPT, it is like you're entering in data, right? And you could potentially be entering in personal data in that interaction, right? Now, that's one thing, right? So it should be seen as no different than entering your credit card information into an e-commerce website. It's like you're still submitting personal data and the things that you're doing. You might be uploading a resume and saying, hey, hey, can you make this better? That has your email, that has your address, that has your job history, that has a whole bunch of information, right? Now, more subtly, right? So that's kind of a classical cybersecurity problem with like a new twist, but all sorts of new cybersecurity problems arise as well, right? Like, let's imagine that you're a company and you want to build an access control interface to your large language model. That means that it needs to say some things to some people, but other things to other people, right? Like, for example, if children are visiting your website, you talk with certain language. And if somebody else is visiting your website, you talk with other language. If one of your engineers is accessing this product, maybe you need to break the glass and allow it to have no safeguards on it so they can really debug what's going on, right? Now, we take that kind of access control for granted on good old-fashioned databases, right? I can set up an access control rule that says people from this IP address, people from this region can only access this table, people from here can only access this fact. Large language models, they're fully a data product, right? They're, in many ways, they're like a database. You can ask it questions and it gives you answers. That access control infrastructure doesn't exist, right? Now, I think that when we think about the future of an internet, right, all of those things matter, right? What takes a piece of software from being a demoware and being something that is a novelty to something that is productionized and something that people can use are all of those small pieces.
Okay. So to the average user, will there be a need for much security or at least warnings, like warning anything you enter in here could be used publicly, click here to keep it private? How is this going to differ from like corporations using AI?
Good. So I think the answer is going to be a little bit of all of the above. I think that we still need to understand, how do humans perceive AI, right? I tell students, like, if you wouldn't tell something to a nosy neighbor, you probably shouldn't tell it to a free version of these AI tools. I think that's one way to think about it, right? It's like, who knows what their data retention is going to look like? Who knows if some of that data is going to be regurgitated in the future? We just don't know, right? That's kind of one side of it. I think the other side of it is that, look, I mean, like, there are all sorts of cybersecurity threats that we are talking about now that we weren't even talking about 15 years ago, right? Like ransomwares and DDoSes and all of those arose because of the scale, diversity, interconnectedness of the internet. Now, if you suddenly change the technology, right, and you say that, okay, now these are not just static web pages or database-backed portals, these are actually intelligent agents that have state and so on, interesting problems happen, right? What happens if, let's say that there's a chatbot on a news website that helps you understand what the news of the day is, right? And it periodically uses its usage data to refine its answer. Could an adversary poison that website so that in the future it starts giving increasingly fake answers or increasingly pointed answers towards certain things? That's kind of what I mean by new threats, right? I think that what's really going on here is that this is a new technology, and every time a new computing technology comes out, there's a new attack surface. And wrapping our heads around what that attack surface is going to be complicated, because I am strongly against this idea that it's just simply an end user privacy threat. That's clearly one angle to it. But as we saw with the internet, it's not just a privacy problem. There are all sorts of other things that happen, right? There are like ransomware, denial of service. All of these things organically arose. All of these threats organically arose because of the scale and diversity of the internet. Now, I believe that a whole host of new threats are going to arise in the future of everybody's using an AI tool.
So, like what?
Yeah, I think that the two specific threats worry me a lot. I think one of them is the poisoning threat, right? Because like we've already seen with social media forums that one of the techniques that both illegitimate users use is using bots to flood different types of social media forums with different types of comments and so on to steer the discussion. Okay, so we see that on Reddit, right? There's something political in nature. a whole host of bots come in. Some of them are mischievous. Some of them might be foreign adversaries. Some of them might just be trying to earn a buck. Some of them might be phishing, right? So we've spent the last decade wrapping our heads around how do we deal with the bot threat, right? This is tools like Cloudflare and so on that do behavioral analysis on the types of interactions you're having with the website. Are you a human? Are you a bot? They look at your IP address. They look at your behavior. They look at repeated posts and so on. They look at the language content in more advanced tools and so on to figure out, is this a bot trying to steer a discussion? Now, let's imagine we had a chat bot and we believed everything we were just saying, that really the power of some of these chat bots is going to be able to leverage that usage data and get better over time. Could a bot ultimately steer a chat bot to do something weird in the future? To, for example, let's say that, I'm picking a particular country, but a country, Polonia, some made-up country, their premier is very upset about the type of discourse they're having on American news. So they poison one of the chat bots on a future news website by just priming it with different prompts, just to get the association between premier and good. Again, these things work on correlations, right? Those two things are just seen in so many different comments that it eventually gets a positive leaning to, right? To me, that is a much harder threat to deal with than the Reddit comment forum, right? That it's like a bunch of bots spamming a comment forum where you see all of them and handle this, because this is a completely new attack surface. You may not be able to reproduce this problem readily on certain prompts. This is a much harder problem to deal with. So poisoning is one thing that I worry about. Is, again, it's a brand new threat, right? The second threat that I think is also interesting is, like one of the things that is drilled into us as people who program internet tools is never mix code and data, right? So it's like, there are all these comics, like you always sanitize your names and passwords, because if somebody names themselves, the joke is Bobby drop tables, it might hit your database and drop your data, right? So like you always want to make sure that user inputs are 100% sanitized. Guess what? For an LLM, code is data and data is code. So all of that is completely commingled together, right? Could a user who asks enough questions of a large language model figure out some of the proprietary details on how it was built? Possibly. Could a user who asks enough questions about a large language model to poison it? Absolutely, right? So these are the types of threats that I think about as like, this is uncharted territory for the internet. And right now, saving grace is that there are only a handful of providers that are really running these at scale. Let's imagine a proliferation of this similar to the World Wide Web. Suddenly, the security challenges become daunting.
Interesting. All right. So data poisoning. What's I don't know, what other nefarious uses do you see coming for AI? I wonder if like self-driving cars, is the data there can be poisoned? I guess anytime these systems come into use, you have a trade-off here. Now you're going to be getting, tons more adoption, tons more data, but how do you have a filtering mechanism to make sure the data is useful? And again, like you said, not poison is going to cause a problem,
Good. And I want to also emphasize that this is kind of a fundamental issue, right? You don't get something for nothing in the world of technology, right? Like the reason that AI tools are so good at what they're doing and so good at so many domains is because they're so adaptable, right? That means that they take a little bit of data and extrapolate from them, right? That is like the basic piece, right? The fact of the matter is that we need, like, as big as the internet is, like it's much less data than I would have guessed to build ChatGPT than like 15 years ago, right? It's like a petabyte sounds bad to like the average person, but to me, it's like, well, like, there's a lot of human language out there. The fact that this was a petabyte and not all of the atoms in the universe is kind of crazy to me, right? So it's like, this is like the fact that these models can extrapolate from a small amount of data is their strength and the reason that they're doing things well. But that's also their biggest weakness, right? That a small amount of data, a small amount of priming on especially topics that are less well attested in their training corpus can steer them in very weird ways, right? And this is going to be true whether we're talking about a large language model, whether we're talking about a self-driving car, whether we're talking about any other future AI system, right? If you want to make the system highly adaptive, learning from new experiences, and incrementally improving over time, you have to be very careful of what data you're feeding it, because to make it adaptive, you're naturally sensitive to that issue of poisoning, right? And I remember I had a control theory professor in college that once told me the safest control system is a pet rock. It just sits there and does nothing, right? So it's like utility and safety kind of go hand in hand, right? But on the other hand, a fighter aircraft is a highly unstable system. There's no reason they should be even flying, right? They're the highly finessed computer aided control system, marginally stable. That's the reason they do cool things, right? So it's like I think so. You kind of like this AI boom is a little bit of a double-edged sword when we think about it from both a cybersecurity, but also if we think about self-driving cars and AI influencing the real world, a physical safety perspective. You don't get the adaptivity, you don't get the ability to extrapolate from things that you see without this threat of poisoning.
Okay. What systems do you think are most susceptible to this, and in what time frame? Maybe the next 1 or 2 years, or what?
Good. So I think that when we think about any cybersecurity threat, we have to think about what the stakes are and what somebody could gain by breaking these systems, right? So right now, I think that all the commercial vendors, like I think we whether it's OpenAI, whether it's Anthropic, whether it's Gemini, they all have their weaknesses, and occasionally you'll see a news article saying, "Hey, I got ChatGPT to tell me how to make a bomb, or tell me how to do this," right? Like, to me, that those systems are ultimately low stake. We are not affecting change in the real world. The second that we start seeing the scope of these AI systems creep into real world decisions, that's when we're going to start seeing a redoubled and more clever effort from adversaries to poison them, steer them in weird ways, right? Let's take, for example, a AI system that might be calling an Uber Eats API, right? So that means that you're asking this AI system, you're just telling it in the morning, here's something I'd like to eat, have this ordered by lunch, okay? Now, a nefarious actor on that type of a system could try to find some way of routing different fraudulent purchase orders and so on that never have to be delivered, right? So, like, I think that right now, so far, I think that the threats that we've seen are pretty minimal. I think that if I was to answer your question directly, what types of systems are most susceptible to poisoning, most susceptible to steering, or the ones that we have to care about the most, the second that we make that jump from just the prediction to a decision in the real world, those are the systems that I would worry about the most. So the future of self-driving cars, the future of smart home assistants, smart enterprise admin assistants, scheduling, and so on. That's where I think, because the stakes are higher, there's more to win by trying to break them.
Yeah, yes. We don't know if what jobs will be lost, what jobs will be kept, what jobs will be adapted to work with AIs. Also, too, I mean, if the data system is poisoned and you're working with it in a job for your company, and they want you to work with AI, if it's producing nonsense and you don't look at it and you forward that nonsense on, it could poison the company as a whole. Let's say that you're working with.
Yeah, and I think that it like when we think about modern cybersecurity, it's not just digital threats, right? It's potentially physical threats. It's potentially reputational damage, right? That it's like a one bad email written by an AI system can ruin the brand of your company and might do more like value damage than any hack could ever do, right? We know the world of social media, right? So I think that these are, like, if I was a chief information security officer at a company really thinking about the future of AI, these are all the things that would keep me up at night, right? That it's a completely untested technology that everybody absolutely wants to use, right? Like it's undeniable the productivity wins that you get. Like I use ChatGPT to help me code almost every day, or tools similar to that, right? My wife uses it in her job almost every day. So we are all using this. Now, I think that we as a broader computing community, as a broader internet services community, have to understand the potential threats that are going to exist when these systems are reaching maturity, right? If there is the proliferation that we think there's going to be, I think this completely changes the way that you think about security posture for an enterprise.
I mean, what would that posture be? How would it change?
Good. I think that, I think that you're adding a piece of software that could potentially cause reputational damage to the company in different ways, right? One example of a changing posture might be that you start giving guidance on human reviews on the output of AI tools, right? Now, that's going to be a nasty thing to convince your employees to do, right? It's almost like it's just as bad as two-factor authentication, right? Everybody hates it, but it's a necessary evil. Maybe if you're a company where some piece of data is customer facing, you got to make sure that it's not written by AI, or at least that a human has reviewed it, right? That's an example of a changing posture, right? That it's like you previously, the chief information security officer would never have to consider what the comms department is doing, right? It's like, hey, you guys, we've already put a firewall behind your webpage. You just write your content and you're done, right? Now, the second that you throw AI into the loop, suddenly this starts becoming a more complicated security problem, right? This is automatically generated content that someone might not review, so you need to potentially put systems in place to vet that content before it goes out. I think that, you made the comment about jobs or changing jobs or adapting jobs. And now, if you want to understand how does cybersecurity change with AI, this is a great microcosm of that, right? That you have a traditional role, which was just communications. You put AI in the loop of that. Suddenly, you start having to understand a little bit about the AI technology, what it's good at, what it's not, how to use the AI technology from the comms side. But from a cybersecurity researcher side, you might have been an expert in understanding website security, OWASP, SSL, all of the classic internet technologies you use to keep a website safe. Suddenly, you throw an AI tool in there. Now you need to understand a little bit of all the bad things an AI tool can do, right?
I guess there's going to have to be secondary. There's going to have to be a lot of cleaning and filtering of data. What kinds of things would you look for in a data set to tell you that there's an actor trying to poison it and determine the nature of the poisoning?
Good. I think that herein lies the challenge, right? That this is like the $1 million question. How does somebody look at a data set and figure out it's been poisoned? Like, I would argue that if you're going to have a human go through this data set and review record by record, we've kind of defeated the purpose of AI in the first place, right? The whole reason that these AI models are great is we can put in an enormous amount of data that no individual human could curate on their own into these systems. Now, many of these AI companies do simple rule-based curation. They have complicated data extraction pipelines that get you there. But second that you need a human to vet everything that the AI is saying, we might as well have just made this a call center operation, right? That is like Wizard of Oz behind the scenes, right? So I think that this is a tricky problem, right? How do we figure out that some content is meant to poison or steer this AI system? I think that, again, the answer is going to come down to usage. And it's going to come down to us really understanding what typical users do with a system and what an adversary might do with a system. While you might not be able to tell from their data that this is something meant to steer an AI system, you might be able to tell something from their behavior, right? This is coming from IP addresses that we don't often see. This is coming from this traffic is coming in a pattern that we don't often see. Maybe it's cut and pasted text that we don't often see that much of in our system, right? Those are the types of things that I would look out for. Or like this training data was taken from a slice of websites that just cropped up in the last few months, right? So I think that the cybersecurity solution here is not going to be a pure AI solution, right? I think that everyone's hoping for, I'm just going to be able to build a smarter model that just ignores the bad data. I think it's going to be more leveraging what we've learned with protecting the internet as it is today and bringing that into the world of AI, where we can understand behavioral signals, data-driven signals, as well as organizational signals and like safeguards on code reviews and reviews on people adding things to the data set and so on.
Okay. Are there any poison signatures that you're already starting to see or people are starting to see? Preferred methods of poisoning and ways to spot them?
Good. So in terms of the types of poisoning attacks that I have seen in practice, there are a couple of different things that people are doing. The first type of poisoning is what's called context poisoning attacks, right? Where you're really not trying to break an AI system long term. You're just trying to get this AI system to do something that it wasn't supposed to do. So this is like tools like ChatGPT, tools like Gemini, tools like Anthropic have a whole battery of safeguards to prevent these tools from saying something wrong or doing something weird, right? Saying something weird, saying something offensive, or telling you how to make a bomb, or doing something illegal, right? Or saying something illegal, right? Context poisoning attacks are ways of framing the questions that you're asking of these AI systems so it doesn't fully stop you from doing that. That's one set of poisoning attacks, right? So now if I'm a company putting a service out there, those context poisoning attacks are ones that could cause reputational damage, right? Somebody could take the disastrous screenshot of your system doing something wrong, right? That's one set of problems. I think that the context poisoning attacks, I think that as we start getting better with understanding typical usage patterns and trying to circumvent these things, we're just going to get better and better and better. There's not going to be any silver bullet to that. The same way that there isn't a silver bullet to somebody hacking a website, right? That it's like passwords are still insecure today because eventually people can guess your security questions and so on. I think we'll see a similar incremental improvement of security and context poisoning. Training data poisoning, I think, is a much harder challenge, right? That it's like when somebody tries to sneak something into a training data set, whether this is a disgruntled employee inside the company that has access to the training data set, whether it's somebody who understands how data is being passed from usage data back into the future training data sets, or figuring out where this data is sourced so they can poison it. This is all, I think that is an uncharted territory right now. And I think that there are a lot of researchers that are trying to come up with a solution. I personally think that some of that solution is going to be much better understanding of data provenance and much better tracking of data provenance. Where did data come from? Watermarking solutions to say that this came from this type of a website, this came from this type of a website. I think that all of those are going to be things that are at play. I don't think anybody has I think that if you're asking, is there a nice digital signature equivalent for data? I don't think that there is one right now. And I think that people are trying to, again, strike that balance between not having a human vet every single piece of data and treating these models securely.
Okay. Any recent surprises or disruptions? I mean, maybe it's a laughable question, but even to you, someone that pays attention to everything going on in AI or as much as they can, like what is surprising you that's coming into availability or use just now that maybe it will change the picture totally?
Good. So I think that there are two big things. So, the day that ChatGPT came out, I played with it for like 3 hours, right? I mean, that's kind of my personality. Every tool that comes out, I play with them. I probably have $100 a month of subscriptions to various APIs, right? So I've played with all of these. Two things that I think have been very surprising over the last year have been how good the coding assistants are, the programming assistants are. I have kind of been blown away over the last 6 months of how much they have improved and how good they are at writing. Not perfect code, not anything that if I was hiring a software engineer that I would write, but great starting points that clearly make my life more productive as a person who codes a lot, right? So I think that the first thing that has kind of blown me away is the progress that has happened on coding assistant, meaning to the point that like this completely changes the way I teach an introductory programming class. Like I am still like unclear how we handle this in like a university, right? This would solve pretty much every homework assignment reasonably, right? That's kind of the first thing that was blown me away. The second thing that I never thought was going to go as fast as it has is multimodal reasoning over images, text, multiple file formats. That has gotten much better very, very quickly. And again, like I wish I was a fly on the wall in some of these companies to understand exactly the technical trade-offs that they made to make that so quick, but multimodal reasoning, the fact that I can upload an image to ChatGPT and ask it questions about it or ask it write an essay about it, that's still magic to me. That's like because that kind of breaks my monkeys and bananas model, right? This is now a complex reasoning over images and text and somehow cross-correlating the correlations between them and understanding the semantics of an image. That to me is going to be where the breakthroughs happen. It's like if we think about what self-driving cars have to do, it's really complex multimodal reasoning. So those are two breakthroughs that have happened in the last year, almost silently, that no one really talks about. That from me playing around with these tools in 2024 to playing around with them in 2025, it's been night and day.
Oh wow, okay. I guess in the next year to go beyond that's probably impossible. But what do you expect to see and be able to do with AI in the next year? Be able to work on.
So I'm gonna get on a soapbox a little bit and think of it, and this is where I would like. This is less about what I think is going to happen, but more what I would like to see happen. I'm really a belief that, again, when we talk about this idea of these models specializing, and that's the sustainable market strategy for many of these companies, that each one of these models is going to be good at a certain class of things and really good at that certain class of things. I think that the types of tools we're going to see in the next year are going to combine multiple different models and multiple different services together. Because I think that that's in many ways similar to human intelligence, right? Like we don't have single Renaissance people that do absolutely everything and are genius at absolutely everything. We leverage each other's expertise to build things that are better than the sum of our parts. I think that that is going to be the innovation of the next few years. Now that these tools are out there, now that they have mature APIs, it's not that hard to build wrapper applications that leverage the best of multiple different models and potentially the best of multiple different models in your own proprietary model as a company, right? Or as a developer. I think that that's where the true power of these models is going to come from. It's going to be the horse trading of information between these systems and somehow the fusing of their decisions together. And I think that that's where I think we'll see just as I said, that multimodality kind of has blown me away. I think that there are going to be all sorts of new apps that connect multiple intelligent APIs together and in complicated feedback loops, right? Like Gemini asking ChatGPT a question, which then asks another API a question and then builds a consensus on what the decision needs to be. I think that that's where this field, I'd like to think that that's where the field is going to go. And, the title of this podcast talked about emergent behavior. That is as emergent as you get as behavior, because I really do think that is where I would like to see the AI field going, where we have not just one single model that we think is the best, and that is the pathway to intelligence, but really the marketplace of models where they can all communicate with each other and they can all interoperate with each other. And some of those models might not even be models. They may be good old-fashioned databases. And we communicate all of that information and integrate all that information together. And that's emergent behavior in the sense of that's a lot like how humans do complicated things.
So yes, in the very near future, it's starting to happen already. You'll have a whole bunch of models that will work to answer your query, and then you'll be able to choose between the model answers, or you can be using that.
Or they choose by themselves, right? Yeah. I mean, like we're already seeing this in enterprise large language models. There's a architecture that is emerging called retrieval assisted generation, where somebody connects a database to a large language model. That can be seen as like a consensus of two people, right? You kind of have your large language model, which is your creative, and your database that is your librarian, right? So the creative and the librarian is kind of the that two-person team is the architecture that is emerging in many enterprises that need some factual guarantees around the data that they are shipping out of the model. Now, I'm just looking forward as like, why just a two-person team? Why not a K-person team where you have N databases and P large language models that can all develop consensus on each other and they're all good at different things and they all eventually can learn each other's strengths with enough usage. And I think that to me is going to get us the most incredible applications, because you can really think of it as a force multiplier, right? That it's like, not only do you have the specialization of the training data that each of these models have, so have the expertises of the AI teams that built those models separated out, right? So I think I think some of the most interesting applications will not be a single model, but it will be some kind of a interesting consensus or network of these models or network of intelligence systems together.
Interesting. Okay. Well, very good. What's the best way for people to, follow your thoughts and your work and keep tabs on your research? Where can they go?
Great. I have, again, I want to wrap up by saying thank you. I love talking about this stuff. And again, it's one perspective. And sometimes just the process of talking about it helps me formulate my own thoughts about this. To follow me, I'm not a big social media poster. I have a LinkedIn. Sometimes I occasionally put thoughts. You can see thoughts from my research at the university. Sometimes you can see my thoughts from a startup that I've also been working with for the last 3-4 years now. So all of those thoughts are out there. Follow my research. My personal website, sanjayk.io, is a great place to start. It tells you about all the cutting edge work that we're doing at the university.
Okay. Well, very good. Well, thank you so much for coming on the podcast. I appreciate it.
Of course. Thank you for having me. This was a lot of fun.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.